Is Tesla's 4680 structural battery pack serviceable? Tesla's structural battery pack that contains the bigger 4680 type cells is yet to be produced in high quantities. But even so, the American EV maker is making efforts to ramp up manufacturing as quickly as possible. At the end of last year, Tesla managed to reach an important milestone: 1,004,680 cells made per week, enough for around 1,000 Model Y vehicles. Subsequently, last week, the American brand started selling a new version of its crossover, which is rumored to be powered by 4,680 cells. So, with an expected ramp-up in production, some people are asking themselves if the new structural battery pack can be repaired in case something goes wrong with it. And it appears that none other than Sandy Munro has an answer for this, but it's not as straightforward as it might seem at first glance. Talking with Peter Gruber from the Gruber Motor Company during a podcast, Sandy Munro, whose team previously disassembled a 4680 pack, said that the secret to opening up the pack is using a dry ice blaster to remove all the putty that seals all the connectors in place. However, using this technique, there's a risk that some of the connectors that are linked to the individual cells might break. Additionally, there's the issue of the stubborn top plate that seals the whole pack from the elements. After the initial Munro live teardown, the conclusion was that the whole pack became a reclamation project for recyclers if it were to fail. Now, however, it seems that there are some ways of putting it back into use, but it's not easy. As suggested by Sandy Munro, who cites Tesla employees, the cells themselves have a pretty low failure rate at the factory, while the complete packs register an even lower rate, which should provide some peace of mind for owners of vehicles fitted with the structural battery. As always, we'd like to know what you think about this, so head to the top of this page to watch the embedded video, and then let us know what your thoughts are in the comments section below. Source: reposted and summarized from Julian Nystrom at Inside EVS.